USB-C power supplies that support power delivery, or USB-C PD, are very useful because you can use them for powering other appliances or devices that don't have a USB-C port on them, or for powering your own projects. All you need to do is get hold of USB-C PD Decoy or PD trigger boards and adapters, which you can search on AliExpress, eBay, Amazon, or other places. You can get them in form of a cable, which already has this standard barrel jack which fits a lot of devices. You need to buy the correct voltage because this plug has one of the PD Decoy devices inside it set to a particular voltage, usually 12 volts for most devices. And when you connect that to your power supply, we use a meter to confirm, it will ask the USB-C output to provide 12 volts. You can see there it says 12 volts, 1.25 amps. Even though it says 5 amps on it, I think that's a bit of a... 5 amps would only apply to the 20 volt version, and I think the 1.25 amp is a limitation of the power supply. It depends on what modes your power supply supports. If we try these bigger ones, that's all you're going to get. 12 volts, 1.25 amps. Different to what I was expecting, but there you go. For laptops you can get these sort of adapters that do the same thing. Most laptops run around 20 volts, so you can use these to make it USB-C powered. You have to be very careful to make sure your laptop doesn't need to draw more than 100 watts, otherwise you're going to run into problems. See, that one there correctly identifies that to the power supply that it is 100 watts. You have to use a cable that's capable of that power level. The power rating is normally written on the cables, 100 watts. If you used a 60 watt cable, then it's not going to work. Well, it won't work up to 100 watts. It will limit the amount of current. So we already covered this stuff back in episode 26, I think, a long time ago. But since then, a few exciting things have shown up. You can now get USB-C PD3.1, which increases the maximum output voltage of the power supply from 20 volts up to 28 volts. And some power supplies, some of the bigger ones, support that. This one here has a PD3.1 output. It goes up to 140 watts, which means 28 volts, 5 amps. This new 150 watt version from SlimQ, these top two ports can do PD3.1. And finally, well, I don't know how long they've been available, but recently when I searched, you can get now these decoy boards for PD3.1, which these two are. And this one here was the first one that became available that I found, but this one you have to manually select the voltages, which means it's not really good for sticking in a project because it won't remember the output voltage. It will always go back to 5 volts when you plug it in. So now for your higher power devices, as long as you've got a power supply that supports it, a cable that supports it, which will mean one that says 240 watts on it, then you'll be able to run things with 28 volts. This here will automatically go to 28 volts. But if you plug it into a port that supports only just normal USB-C PD3.0, then it will go to the highest it can, which is 20 volts, 100 watts maximum. The same thing with these little things. 28 volts. Weirdly, that says 15 watts. I don't know why. There you go. I feel like this cable here is dodgy. It's the thinnest one I've found that can do 240 watts, but I think it's missing some cables because that's the second time it's showed something weird. So we put that to the side. What I found is a lot of the cables that support 240 watts are extremely stiff and thick, which is quite bad for your delicate little USB-C plugs. So be careful with what you buy. You might have to get a range of them. This one here isn't too bad, but it's still quite thick. It's a bit of a gamble buying this stuff. So you might need to buy a few to find something that works properly. Maybe it's the adapter that's got the problem then. And it seems like it will only properly detect if you connect it around the right way. They probably only wired one of the CC lines onto the USB-C connector. Something to watch for. We'll see if this thing is the same. No, it's right around both ways, so that's possibly the better buy. It comes with this plug on it, so you can plug it straight into things, but I wouldn't recommend that because it's got a lot of leverage unless you're plugging it into a socket on a cable. So what I've noticed with these power supplies, both of these 140 watt power supplies, is if you're using any of the other plugs, then the PD3.1 won't go to 28 volts. It will drop down to only 100 watts, 20 volts. Something to keep in mind, because it seems useful, it's got lots of plugs, but if you actually want to get the 28 volts, you can't use any of the other plugs because they only rate it for that one going full power. Otherwise they have to downrate that to 100 watts, so there's some power left to use, or some capacity left to use the other ports. Another thing I was asked recently was, what about PPS? So there's another standard, I think it's part of the PD3.1, not really sure. It's another mode that the power supply can go in. So USB-C PD supports 5, 9, 12, 15, 20, and now 28 volt outputs. But there's another mode you can use called PPS, Programmable Power Source. I think something like that. Programmable Power Supply. And you can trigger, using this board, you can get the power supply into that mode. If we have a look down there, it says fixed 5 volts 3 amps. Still says that. I guess it doesn't update very well. There you go, 9 volts 3 amps, 12 volts 3 amps, you jumped one, 15 volts 3 amps, 20 volts 5 amps. Now we're in PPS mode, 21 volts 5 amps. So the interesting thing about PPS mode is it's always 5 amps, and the voltage is variable from around 3.3 volts up to, I don't know, 28 I guess, or maybe 20. And if we go beyond PPS mode, it goes into PD3.1, 140 watts, 28 volts 5 amps. The reason why they rate the cables 240 watts is because this standard should eventually go up to 48 volts at 5 amps, which will be 240 watts. So if we put it into the PPS mode, now what this allows you to do is to configure the USB-C power supply to output any voltage from 3.3 up to 20, maybe more, in, well, obviously more because it's at 21 right now, in 20 millivolt increments. So we can use these buttons here to change that voltage. You can see it's now at 20.88. How close can we get this? 20. Oh, it's going down by itself. Yeah, so it's lowering the voltage. I push the other button, it stops, so it's at 19.94. If you hold this button in, it will go to the lowest voltage, which is 3.3. It's not enough for that screen to come on. The voltage is too low for that. Although if we plugged in another power supply into the side of this thing, we can get it to come on. Find another cable. I'm just tangled around everything, of course. Yeah, so if we power this externally, now we can see, so it's gone down to the minimum voltage there, 3.3 volts, 5 amps. And then if we click these buttons, you see now it's Oh, it's going up in steps by itself. Yeah, 3.3 rising up, and then you can click it again to stop when you get to the voltage you want. It's extremely tedious because, well, this isn't an actual, this is just for testing. If you want to use PPS on your own project, then you'd need to find a USB PD microcontroller with PPS support, and then you can program the voltage that you need or want. This board you can buy on AliExpress, you can use for testing the capability on the power supplies. I guess that EPR is extended power range. I don't know, they've come up with so many. Seems to be a problem on that screen as well, doesn't there? Some like burnt out pixel thing. Anyway, that's PPS, and I think it is supported on most power supplies. Let's try some other ones. This really tiny Lenovo charger, just one output, but it's 65 watts, this tiny little package. That's pretty good. I think that's the smallest one I've found. It's got the folding pins, and it's slightly smaller than this Slim Q, which doesn't have folding pins, and although it has the extra USB-A. Let's try it. Let's see what this supports. 5, 9, 12, 15 volts, 20 volts, 65 watts. And, oh, look at that, it's got a PPS mode. Well, it's limited to 4 amps. If we click this, okay, it looks like that PPS goes down to 5 volts, 4 amps, and might only go up to 11 by the look of it. So yeah, the range of PPSs available will probably vary depending on what power supply you've got, but it's only really going to be useful if you've got the microcontroller and you can program it to something useful to you, something I've not looked into before. So this has PPS as well, up to 16 volts, 3 amps, down to 3.3. Oops, I think it dropped out of that mode. Some power supplies don't like it when you keep changing the voltage on them or do it too quickly. Yeah, that seemed a bit grumpy about it. So this adapter here has got, just jump around to different subjects. The PD trigger boards usually have a way of configuring the output. It's like it will do quick charge or PD depending on what your power supply supports. And by adjusting these switches, so that solid block is represented by the solid color there, meaning like the switch in a particular position. Although this only does up to 20 volts, but you can easily set the output voltage. It's useful to have one of these meters. There's various types around to confirm the output voltage, otherwise you might blow up your device. This one here, I don't think it's configurable. Well, maybe if you peel the heat shrink off and change these resistors, maybe, I don't know. These ones here, little tiny ones, there's a whole range of different ones like this, but see, it has a high-low thing. Presumably that would change the voltage, not sure. But you can usually buy them in the voltage you want. But beware, if you want to power fairly high-powered devices at lower than 20 volts, like 12 volts, then you're probably better off using one of these high-efficiency switch mode power supplies with a 20 volt PD trigger, and then set that voltage output to 12 or 15 or whatever you need, because these power supplies can be quite finicky about the load current being drawn from them, and as you saw, some of them don't trigger like the full 3 amps at 12 volts. They'll go to 1.5 or something else. So if you've got quite a high power device, or a device that draws large spikes of current when it turns on or off or changes modes, then you're probably better off triggering PD 20 volts and then using another regulator to create the 12 volts, because that will buffer the device. Your mileage may vary, but I've found that that makes it a lot it makes it more stable. The other thing you got to be very careful about, if you're powering some critical device through one of these PD and you plug another device into a connector of the power supply, usually all the outputs will turn off briefly. So be careful, because you might briefly lose power to what you were powering. So it might be best to stick to the single output power supplies. Well, I think the more fancy ones can switch modes without interrupting, but definitely if you're doing the 28 volt output, you will only be able to use one connector. Does that cover everything? Oh, obviously, I think I already said, if you're using a lower rated cable like this 100 watt cable, then you'll only be able to get up to 20 volts from your PD3.1 power supply, because there's a little ID chip in the cable that identifies its capabilities to the power supply, and it won't let the power supply will not go to voltages that are beyond the capability of the cable. And be aware of ultra thick stiff cables, because you can damage your USB plugs by yoinking on them. It's quite bizarre really that they use such a flimsy little connector. I think the USB-C connector should have been recessed in a bit, and this molding shape around it standardized so that when you plugged it into a device it goes in some way and then you get a better mechanical restraint. So these little thingies that do 12 volts and bring it out to a barrel jack, I've been using those to power devices like the fiber modem internet router. That kind of stuff comes with some very cheap poor quality power supply, so you can replace that for a much more efficient high performance power supply and maybe save 5 cents on your power bill over the course of a year. Great. Well, at least you're using a good power supply, and that's exciting. It also means when the power cut, you can get your USB-C PD power bank, plug this in and get your internet going again. Let's do a thing. You can get these again, AliExpress. Everything comes from AliExpress these days. It's a little programmable power supply. Very useful for testing out things, as long as you absolutely critical that you power it from an isolated power supply that isn't connected to any other devices, because the ground on the input is not the same as the ground on the output. There's switching and regulating going on in there. To avoid blowing things up, do not power these from a common power supply. They must have their own isolated power supply. I was using it to run this fan to keep some NVMe drives cool while copying lots of data. So you can see there, the input voltage is 20 volts, and that's because it's got a PD3.0 20 volts trigger. This power supply can have, I think, up to 35 or so volt input. So today, let's change it to use one of these new 28 volt PD triggers. I think those are both the same, and that way we can get more power out of this, and we can go up to higher voltages, like putting the output at 24 volts, which would be useful for some devices. So we'll solder some wires onto this, and then we can use it. Well, then we'll test it, just for fun, because we're talking about USB-C stuff. We can use this soldering iron to do the job. It's good that everything's matching colors. There you go, look at that. About 40 watts when it's running. It's 20 volts. And once it gets up to temperature, about 350, it will throttle down to a power level to maintain the temperature. I found some nice wire, and these things here usually give you, on the back, as well as these little terminals for soldering the outputs, positive and negative, they've also got these larger areas which you can use for soldering onto thicker wires. Just got to be very careful that you don't scratch away any of the solder mask on those other tracks and short them out. It's also going to be a lot better to stabilize it by plugging it into something while soldering it. Let's just tin this stuff to get it going. A nice lead solder into there. Good quality, made in Japan, Goot solder. Now we strip these wires, They're good silicone insulation, so it's pretty nice stuff. Tin the ends so that it's ready to receive. Good thing about that silicone insulation, doesn't peel back and melt. Now I'm going to work out the polarity, and that needs to be right. It needs to be correct. You can see there that the positive is marked by a little bit of solder on there, and that goes up to that one. So that one's going to be the positive pin. So we'll do that one first since we can access it. That will squish down nicely onto there to hold it without burning my hands too much. There we go. Solder's not a very good conductor, but anyway. Squishing the cores of the cable down along the pad area will help. Oops, got too hot to hold. Okay, you can see when the solder's cooled enough because the color changes very slightly, or the appearance of it changes very slightly. Somewhat attached. It's kind of crusty, but that's okay. I'll get a nice bit of heat shrink around that. Get these good sets. Everything comes from AliExpress. Just power this thing off. Make sure to leave the soldering iron tip cleaned and tinned so that it stays nice, ready for next time. Now you get these nice sets from AliExpress of support your local retailers. Various sizes heat shrink. So good to check. You can find one that's a very close match to the size of the thing you want it in, so it doesn't have to stretch very far. Then it can get in there nice and tight. Don't even have to shrink it most of the time if you can get a good fit. And just to stop it shorting out by touching random things. Pretty important it doesn't touch random things. So that's good, ready to go. And we'll just twist these a little bit. Is this good? Watching just some random thing being assembled, where I could just skip to the end and say, look, it's done. The plugs they put in these are pretty low quality. Phoenix contact type things, but these are, it's a little bit annoying. You can't just use the standard plug because this is a lower height than usual, and so it clears that, which means it sits on the bench nicely. So if you use a normal plug, then this thing sits all up on an angle. See, these aren't nice rising clamp connectors. They've just got that little tongue thing in there which gets munted after a while. So if you fold the wires over, then you can get a nice contact area in there, and just squeeze those little terminals down so that it makes a good amount of space for you to get the wire in there without messing up the lay of the cable. Now, because those were offset, the length is a little bit varied, so we can get those back to the same, and then strip these a reasonable amount so that there's room to twist them and fold them over. Always twist them nice and tight so that the strands are all well held together, and give them a nice fold. Then we can put them into here very carefully so that we don't mess up the fold. Make sure they're definitely in far enough so that there's no stray strands poking out. Do up that one first, then we can bring this over. Yes, nice and tight. We should do a check before we turn this, or before we plug this in. Make absolutely sure that that is around the right way. Plus in there, red. and that the red one is actually the positive terminal. It's very important. You don't want to blow this thing up on the first try. So critical to check and double check things. So if we plug it into just this regular not 3.1 power supply, we should get 20 volts. Like that. And then we can check it with the meter to make sure probes are around the right way in the meter. Very important. And look at that. We can tell that that's the right way because it doesn't have a negative sign there. So if we connected the probes around the other way, red to black, you can see it's negative 20 volts. So that means that it's a reversed connection. But connected the right way, red to red. Red is red on the multimeter, very important. Then it shows 20 volts. So we know it's wired around the right way. I'm not going to blow it up. Always make sure the meter's not connected on current mode either. So we can connect this up. "20 volts. Great. So we can run the fan. Or whatever other device you want to test with. Let's try it on the PD3.1 power supply. This good orange one. It's still 20 volts because we're using a 100 watt capable cable. So we need to change that. Just to check. And go for this 240 watt cable. "28 volts. It says 28 volts there. That's nice. Still about 9 volts out because that's what we've configured on this power supply. But it means we can now dial up voltages on here above 20 volts. We can go all the way up to 27. So we can set the output to 24 volts to power a 24 volt device. Don't run your 12 volt fans above 12 volts for too long. Great! So we've improved the capabilities of this useful little power supply. It can now deliver more than about 19 volts. It can go up to 27 volts. And the power is much higher because we now have up to 140 watts. Great! Is that all the information we need to deliver at this time? It's unscripted and unplanned. If it seems useful, although it's still equally waffly, I might include a brief bit that I did about these things on the last week's live stream, just for fun. We'll see. Anyway, next time we'll look at VCRs and things. Problem is there's work and then other work going on, and it's hard to find time to do video recordings, so I did this kind of quick one. And since someone had asked about PPS, but there you go, you can use these PD triggers in your own projects or to power devices conveniently by USB-C. It is useful, and just be careful to check everything before you plug it in so that you don't blow up your expensive devices. There is one more thing. It's peripherally related, tangentially related, somewhat related. I got a laptop. I bought a new laptop, and it came with one of those dumb, annoying power supplies that's not USB-C. It didn't have any mention of USB-C charging capabilities, but it has got two Thunderbolt 4 ports, I think that they are, USB 4, whatever the latest thing is. And nicely, I was able to discover that it does do USB charging up to 100 watts. It says PD3.1, but it's 100 watts, not 140. So it seems to be up to the latest standard, but the way they've designed the power supply, in the computer it can only draw up to 20 volts. So you can run and charge the computer from USB-C, even though that wasn't an advertised feature as far as I could see. Very nice. It's also very nice to have a computer with two screens on it, because you can fit extra stuff down here and work on the top, extra file explorers and whatever down on the bottom screen. It's very nice. It's also nice that the screen is 2800 resolution, so with no zooming or stretching, you get a pretty productive area to work in, but you just have to sit a foot away from the screen to actually see any of the text clearly. Okay, there you go. That's USB-C PD. Make your devices nice and easy to power, but just do it in a careful and well thought out manner. I'll just get some exhibits since you wanted to see what was going on. This is a problem that I don't seem to see anyone else having, but has caused me major issues. That when you join a USB to SATA adapter to a modern computer that's got USB 3.2, then you end up corrupting the drive. I have no idea why that happens. Don't seem to be able to find any evidence of it occurring for other people when searching. So you get things like this that you put SATA drives in and it turns it into USB. And for some reason those just don't work on any computer that I've tried which is newer than about 8th gen Intel, because the USB 3s are newer, and tried about 4 or 5 different SATA to USB things, like these cheap ones you get on AliExpress, other brands ones, and also those other type that you get from StarTech, which are pretty expensive and generally work well. And I don't know where it is now, one that just plugs directly onto the end of the drive. So because I got a new laptop now that's newer than 8th gen, haven't dared to plug my drives in, I found you can get these things, which is NVMe PCIe, and then it's got a USB controller on it. So I've built that up here. So it's a Thunderbolt NVMe adapter, which now goes to USB 3.0, and I'll put the USB header on it. So now in theory, because that's an older USB controller that's only USB 3.0, the 5 gigabits per second, not the newer 10 gigabits one, it should be able to work with these drives without corrupting it. But I haven't been brave enough to try it. I only just plugged this together a short time ago. But at least this works. That comes up on the computer as a USB controller, and things like thumb drives mount on it. What needs to happen, because USB needs 5 volts and the NVMe slots only provide 3.3 volts, they've got this connector here where you wire like a disk drive power supply cable into it to provide the 5 volts for the USB. This one here has got a boost converter on it, so it can turn the 3.3 volts from the slot into 5 volts, but that will be quite limited power. So what I'm going to do is probe about on this board while it's hooked up and find out where the 5 volts is that comes from the Thunderbolt port, and then you can solder a wire from there up onto the right pin of that. And then if I prove that this works with the drives, then I'll take off this connector and get one of these, cut it, solder it on directly, and then can just have that poking out of a case so that it's ready to go directly onto the drive. That's my plan, to be able to use drives, because I've got a bunch of these I use for doing backups, an 8 terabyte one and a couple of 4 terabyte ones. Oh look, here's one of the StarTech ones. It's just sitting over here. That one's got a 4 terabyte drive in it. Those fancy Samsung ones for data centers, so it's gonna last a long time. But yeah, I ended up corrupting that trying to use it on a computer once, a newer computer, and then had to format it and recopy all my data. It's not very good to have a backup which is unreliable. So that's the plan around it, to use Thunderbolt, then turn it into the right the older type of USB 3 and then plug it into the drive. That goes in a little case. That thing. So it'll go back in there and then I'll make a hole in it for the wire to come out. Assuming that works. We'll see, maybe I'll make a video about that. Oh, we already did, good. The other thing is, you can now get the USB PD Decoy boards, or is that what you call them? USB-C PD triggers for USB 3.1. So when you got a cable that can do 240 watts and a power supply that can also do that, you can now get 28 volts out of them. 28 volts for up to 140 watts. The first level of PD 3.1 is achieved, which is quite exciting. There's that one there which turns it into a barrel plug. Pretty dodgy, so you can plug that into a 12 volt device and blow it up with 28 volts. And then there's this one here, which this one allows you to select with these controls through different voltages, 9 volts, 12, 15, 20. That's normal USB PD, maximum of 20. Then it goes into PPS mode, and then beyond that it goes to the PD3.1 28 volts mode. PPS mode is interesting, programmable power supply. Then you can use these two buttons to increase or decrease the voltage in 20 millivolt steps, which is quite tedious, but it's possible. If you hold that one down, it goes to the lowest voltage, which is around 3 volts, which is below the threshold of that screen turning on. There you go. As it gets to about 3.7, it turns on, and you can see the voltage is slowly increasing as I press this button. About 20 millivolt steps according to the standard. So that will allow you to join up or to draw up to 5 amps at pretty much any voltage you want, which you specify or tell it to. So ideally in an application you'd have a microcontroller that is programmed to ask for a voltage directly, but for testing you can use this thing to dial up a voltage. But it's extremely tedious because the voltage steps are so tiny. You can hold it down. Well, if you hold it down it jumps to some common voltages, and then you can go from there. So there you go, that's USB-C PD3.1. Yeah, I should probably make a proper video about that because somebody was asking me about PPS things the other day. Okay, I need to go now. Thanks for coming to watch Tetris and play with other things. And don't forget to come back next week and we'll try again to get a good high score in Tetris. For now, I'll see you later.